So we didn't have time to get all the way through the discussion that I'd planned today. No regrets on that. I fully enjoyed the discussion that we had about the COVID-19 reporting page. But I did want to go through this because I think it'll help you, especially as you get ready to do your lab this week. So this example is a simulation-based test for one mean, and we're looking at some data that I collected last year about the sleep habits of my students in 2100H, where I asked them how many hours of sleep did you get last night. So you can see in this dot plot what their responses were. The mean amount of sleep was 6.797 hours, and the standard deviation was about 1.5 hours. The sample size is 48 because I'm putting together data from two different sections. So our question is, does this sample provide convincing evidence that the true mean amount of sleep is less than the recommended 8 hours? So basically our null hypothesis is that people are getting the recommended amount of sleep, that the mean is 8 hours. And the alternative, the thing that we're trying to prove, is that 2100H students are not getting enough sleep. They're getting less than 8 hours of sleep. And we'll analyze this data using the ISI applet for one mean. So the default in this applet is to look at this population. So you can see that this population is centered at 8 and it has a standard deviation of 1.5. And I'm going to repeatedly sample from this made up population. So I'm going to take samples of size 48. So this matches the data that I actually collected in class. And if I draw a sample, I can see that I've selected 48 people from that population. We've got the dots, and that 8.1 is the average for that sample, and 8.1 is then being plotted in the graph on the right, that third graph. So I'm going to do a lot more of these, and it takes a little while on my computer. And now on the right-hand side in this third graph, I have a distribution of sample means. So I just went through this really quickly because I really want you to reason your way through this example on your own. And even though we didn't do the Socrative questions in class, I went ahead and opened up some Socrative questions for you. So log in, go to room name case 216, and there'll be some questions for you to answer about this scenario. So you can see the full list of questions here, and then the answers are on the next page. But I would recommend go ahead and put your answers into Socrative, just because forcing yourself to write something down before you look at the correct answers, that's going to give you a better sense of what you really know. Pause the video here while you answer these questions, and then when you restart, I'll talk through the answers. So the first question asked whether the made-up population was appropriate, and the answer was yes. So if we look at the shape, center, and spread of this population, you'll notice that in a lot of ways it matches our sample data. So the spread of the distribution is very similar to our sample. Also, it has this sort of symmetrical bell shape like our sample does. But the difference is that the mean is equal to 8. Right? Because we're sort of asking if students in 2100H really got the recommended amount of sleep, would we expect to see a sample like the one we really got? The next question asks about these numbers that describe the population data. These numbers are parameters. So parameters are values that describe the population. And on Lab 2A, you'll see a table that shows you what symbols you should be using. So this is quantitative data. We're talking about sleep times, and these are parameters. So if we wanted to describe the population mean, we would use mu. If we wanted to describe the population standard deviation, we would use sigma. So what about the numbers that describe the most recent sample? Those numbers would be statistics, right? Statistics are numbers that describe a sample. So again, going back to that table, we still have quantitative data, but these are statistics. So if we wanted to describe the sample mean, we would use X bar. If we wanted to describe the sample standard deviation, we would just use S. The next question asks, in these first two graphs, what are the dots representing? Every dot in these graphs represents one person and their sleep times. So like in this most recent sample, we've got 48 people and we have a sleep time for each. Whereas in the third graph, if you think about this as being made of dots, these are not individual sleep times anymore. These are sample means. So every dot in this distribution, this third distribution on the right, represents a sample mean from a different random sample. That's the key thing that makes this a sampling distribution. A sampling distribution is a distribution of statistics. So the next question is kind of related. Why is the spread of the sampling distribution so much smaller than the spread of the population? So it really comes down to remembering that these are sample means. Means are going to be a lot less variable than individuals. Because if we look at the population, there are some people that are getting only 4 hours of sleep or getting 12 hours of sleep. But think about what would have to happen to get a sample mean of 4. You would have to take a random sample, right, 48 dots from this population, and they would all have to be in this tiny area down here at the bottom, right? That's extremely unlikely. What's going to actually happen is that you've got some from the top and some from the bottom, and they all kind of balance each other out. So you end up with means that are close to 8, right? It looks like they really only go from a little below 7.5 to a little above 8.5. And this number that's describing the spread of the sampling distribution, remember that number is called the standard error. And the last question is, does this provide strong evidence? So if we look at our sample value, 6.797, and we count all the ones that are less than that, because we're trying to prove that people get less sleep than recommended, you can see that it almost never happens, right? If you were really taking samples from a population with a mean of 8, getting a sample mean of 6.797 would be extremely unlikely. Out of these 10,000 observations, there weren't any. So this provides very strong evidence that students in 2100H are not getting enough sleep on average. So this may bring up questions of generalizability in your mind. It definitely should. Are these 48 students really representative of all 2100H students? Was the survey conducted appropriately? That kind of thing. And we're actually going to revisit this example later. So I'll have you give me your generalizability concerns in another assignment. You can hold on to them for now. All right, in this last page of the Chapter 2A discussion notes, this summarizes the answers that I've just given. So hopefully this will help you as you get ready to do Lab 2A. But if you run into any trouble, just send me an email, come by my office hours, let me know.